In this example, we're going to basically be doing panning using two different mix modules. Now, there's easier ways to do this just by using a stereo mixer module, which in itself has its own pan control. I'm using a percent knob again. So this is a pan knob, and I've set the minimum to be -100 and the max to be 100. If it's -100, then it will be to the left. If it's 100, then it could be to the right. But you don't even need to display this. You can actually just go and turn all this off. So if I got rid of that now you're going to see an emote, you're just going to see pan. And then you know that basically when it's to the left, it's going to be to the left, and when it's on the right, it's going to be to the right. And what we're going to do, we're going to use the percent knob, and then we're going to use a table to then say what we were doing before was set up the inversion. So obviously I could use this percent knob to turn up the volume, and I'm only really going to do this on amp 1, okay? So we do have the wet signal that is going into the in2 of this mixer, okay? But we're not going to be controlling that. All I'm going to be doing is controlling the pan for dry signal. The same principles are going to apply for what we're doing with the volume levels, except remember I showed the taper when using the table. So we've got the pan knob. Then what I have to do here is adding, because remember the table goes from 0, this is 0 entry, this is number 1 entry, this is number 2. So basically what I'm doing here with the percent knob is I'm adding a 1 to it. And why do I do that? Because the percent knob outputs from -1 to a +1. Now the table isn't going to understand what the -1 is, because it's only going to be able to do for in1, in2, in3, it's going to be 0, 1, 2. So if it receives a -1 value, it's just going to output 1. So now instead of going from -1 to 0 to +1, it's now going to go from 0 to +1 to +2. And then I'm plugging that into a monitor so that you can see what that looks like. And I have to use monitors all the time to understand how these modules work. And then the adder is then going into the tables. So you can ignore these switches for the moment. The table then is like what we saw when we were doing the levels to do the different tapers. This one for left to say that when this is a 0, then I want this to output a 1. Okay, so that would then go out to the mixed left. When this is 0, then the mixed left dry level will be 1. Okay, then when the percent knob is 0, when you add on the 1, that's going to be like a 1. So at the 1 value, this is still going to output a 1. So when these are both in the middle, when this percent knob is in the middle, you're basically going to get maximum of each. Okay, so for the right one, it's the inverse. So when the percent knob is at 0, then this is going to output a 0. When the percent knob is in the middle, it's going to output a 1. And when the percent knob is at +1, this is going to output a 1. As you can see, this is going to be at 0 all the way to the left, and this at 1 is going to be all the way to the right. And the reason why I liked to do it this way as well is because you see now for in2, what we could do is we could change that value. If you find that it's a little bit too loud when they're centered, I think there's a name for that within DAW's pan law. As it sweeps through the middle, you're basically adding the two signals together, and it could be quite a bit louder. So you can set your pan law to be -3 dB or whatever it is, and you can basically simulate that with by using the table. So over here we can go 0.7, and over here 0.7. But you can be testing it out, and you can see whichever one you want. So if I push that now, I'm outputting this table to the left monitor, and I'm outputting this table to the right monitor. As I pan, you see we're at 0%. This is showing you what the value of this adder module, what that's doing. So if we're at -100, the adder is going to be at 0. As you go all the way to 100%, you're going to be at 2. Now in the middle, as you can see now, the left value is going to be 0.7 and the right value is going to be 0.7. But as we start going to the left, then the right starts to turn down and the left starts heading up to 1. And then likewise the inverse when we go to the other side. So you can see how useful these tables are. Now we could do the same thing with a switch. So if I take that like that, and then I'll put these into the monitors. And just, you know, to simplify things, I'm going to get rid of those for the moment. You can ignore these multipliers for the moment. I'm not using them just yet. The left switch is set to 1 to 1 to 0, and this one's set to 0 to 1 to 1. Within the hardware, it's going to be exactly the same as if you were using the table. Okay. I can do the same thing. I'd set that to 0.8. 0.8. The difference between a table and a switch is that for each of these inputs over here that you specified in the table, these are actually dynamic inputs. So you can add in LFO signal values. You can add in any value in there that changes. So you can change it once it's set up. Whereas when you're working with the table, you can't change it. There's no inputs to define what these values are. So you have to go back into Vsig and you can then change these values, and then you have to update the algorithm. Whereas with the switch, you can configure these directly like you would in a table, or you can have these values come from different knob values. So we could still do exactly what we're doing here, but you could have in the user interface, the user could then define different values for these. So if you want to do a special taper, or if there's any kind of other function that you wanted to apply, you can start to see how powerful this becomes. So I generally opt for switches because I've set up tables sometimes, and then I decided I wanted that to be a dynamic input, and then I've had to change that around, and that was a little bit of a pain. So I think switches are probably one of my favorite modules. I think you can start to see though that we would actually have a little bit of a problem at some point. So what we're doing with the pan knob is we're controlling the level of the dry signal. We're basically dominating it to the left, or we're dominating the signal to the right and turning it down the opposite side. But what if you have a level control? And so that's when you start to see, okay, well now we need to actually have both of these systems in place. So we've got the dry wet control, and we've got the pan control. Now how do we let both of these do its job? We're only going to be working with the dry signal. Actually, I'll just delete that completely. Now what we can do is we can have a multiply node. So we would have two of them. So let's take this one here and this one here. We're going to multiply them both with the output from this dry signal taper. And then this is going to go in here. Okay, now we've got the left monitor and we've got the right monitor. What I'm going to do is put that there, put that there, now, and then push that. So just to walk through very quickly what we've got here, we've got the pan network. So percent is going into the adder, it's adding 1, then that's going into the switch so that we can work within a range of 0, 1, 2, okay? And that's for each of these switches. And then we're multiplying the output from this switch and this switch, multiplying it against the taper dry signal. Okay, and then we output those into the mixer. But we're going to monitor this and you can see what this looks like. So let's push this out. So now we've got the pan level, and you're seeing these ones here, the left and the right. Those are the actual levels that are being pushed out to the mix module, and you can see it's quite low. So at 0 we're at 0.4 on each side. Okay, so, and that's got to do with the dry wet signal because we're multiplying it. So when we're at 0, then this should output 1. Okay, so that's gonna, the dry signal over here is gonna output a 1. We've not got the wet signal connected in here, so that's gone to pretty much. Let me just get rid of that monitor. Right, okay, we've kept this all very simple. So what you got is the pan. When you pan it down to the left here, then you can see that the left is going to be 0.5, and over here on the right is going to be 0.5. Now if I turn this down, then we're going to be at the dry signal is going to be a 1 from a dry point of view, but then that's being multiplied with the pan value. Now when we're panned all the way to the right, obviously the left value is 0. So 0 multiplied by 1 is going to be 0. And then for the right hand signal, that's going to be 1 multiplied by 1, and that's going to be 1. But anywhere in between, you're going to get smaller values. Okay, so I hope that makes sense. If you have any questions, I guess it's important to cover, where you can get information, because obviously you can get information from the documentation here. So if you go Windows, module documentation, then you'll be able to see an explanation for what these modules do. Likewise for a multiplier module, or a monitor, or the mixer, etc. And I have to refer to the documentation quite a lot. But you can also talk to a couple of guys on the Eventide Vsig programming thread over at Gearsluts. There's a lot of pages of discussion. The guys are massively helpful there, and it's been incredibly helpful on my journey as I try to get to grips with Vsig. But it's all about just playing around and figuring out stuff. But I hope you find that useful. If you have any questions, fire away in the comments below. Cheers.